December 29, 1940. Franklin D. Roosevelt sits before a microphone in the White House, his voice calm but carrying the weight of a world collapsing. "We must become the great arsenal of democracy," he declares. For millions of Americans listening on their radios, it sounds like a promise. For those in Detroit, it feels like a challenge. And for a handful of engineers and industrialists, especially one named Henry Ford, it becomes a mission that will rewrite the very laws of manufacturing. At that moment, America isn't ready for war. Not industrially. Not psychologically. Not logistically. The United States Army Air Forces possess only a fraction of the aircraft they will need. Production methods are outdated, scattered, and slow. The idea of building bombers on a moving assembly line, the way Ford once built Model Ts, seems reckless, if not impossible. But the world is changing faster than the factories can keep up. Europe is burning. Britain is fighting alone. The Axis powers are expanding at a terrifying pace. And Washington knows that without American industry, the Allies will not survive. Enter Willow Run. Before 1941, Willow Run is nothing more than farmland on the edges of Michigan. Flat, empty, unremarkable. But on blueprints inside Ford headquarters, it becomes something radical. A 1-mile-long factory designed to mass-produce a 4-engine heavy bomber, the B-24 Liberator. A plane so complex that conventional factories struggle to complete one per day. Ford proposes building one per hour. To military planners, the claim is outrageous. To rival manufacturers, it is nearly insulting. But Ford's engineers see it differently. They see a chance to solve a puzzle that combines aviation, logistics, and industrial choreography. They imagine a building so large, so efficient, and so meticulously synchronized that it will redefine how wars are supplied. As construction begins, the concept spreads through Detroit like electricity. Columns of steel rise out of the frozen ground. Concrete is poured day and night. Railroad lines are redirected. Entire neighborhoods prepare for an influx of workers. This isn't just a factory, it is a statement of intent. Inside Washington, some officers remain skeptical. "You cannot mass-produce bombers like automobiles," they warn. They aren't wrong. Aircraft require precision, not speed. Rivets must be placed by hand. Components must meet exact tolerances. The B-24 has over 450,000 parts, more than any aircraft built to date. But Ford believes the question isn't whether it can be done, only how long it will take to figure out. By the spring of 1941, Willow Run is already reshaping American expectations. Where wheat once grew, assembly lines now stretch toward the horizon. Where silence dominated, the air hums with the sound of welding torches, pneumatic hammers, and the thunderous echo of construction. And beneath the noise lies a quiet realization. If Willow Run succeeds, the United States won't just be joining the war. It will be redefining it. In early 1941, the United States faces a contradiction. It possesses the world's largest industrial potential, yet much of its manufacturing capability remains tied to civilian production. Most factories still produce refrigerators, radios, and automobiles. And while American machinery is modern, its transition to wartime output is far from automatic. The War Department needs bombers, thousands of them, but the challenge is staggering. A B-24 Liberator is not a sedan. Its airframe is intricate, its electrical systems extensive, and its assembly requires nearly 1 million individual actions carried out in a precise sequence. Traditional aircraft factories rely on small teams of skilled craftsmen, moving slowly, adjusting each component by hand. That method will not win a global war. Ford Motor Company sees the problem differently. To them, the issue is not craftsmanship, it is organization. If a production line can build 7,000 cars a day, then it can be reimagined to build aircraft. But first, every step must be broken down, simplified, standardized, and distributed across a flow of workers who specialize in one task, repeated thousands of times. The idea is revolutionary for aviation. Aircraft manufacturers warn that Ford is underestimating the sheer complexity of the Liberator. You cannot build bombers like tractors, one engineer famously argues. But Ford's team believes the opposite. The tractor-like discipline of automotive manufacturing is exactly what aviation has been missing. At Ford's engineering offices, teams begin mapping the B-24 into a process chart. Each system, hydraulic lines, oxygen tanks, wing spars, landing gear, becomes a station. The challenge is to convert craftsmanship into repeatable procedure. Where an aircraft plant might assign a senior mechanic to install an entire subsystem, Ford divides that into dozens of microtasks. Measure, align, drill, rivet, inspect. Piece by piece, the Liberator is transformed from a singular machine into a sequence of steps. The scale of Willow Run itself reflects Ford's ambition. The factory stretches nearly a mile end to end, with assembly lines arranged like arteries feeding a single mechanical organism. Steel trusses rise overhead, supporting cranes capable of moving entire fuselage sections. Massive skylights flood the floor with natural light, while conveyors extend across the building like industrial railways. By mid-1941, tens of thousands of workers pour into southeastern Michigan. Mechanics, welders, riveters, and tool designers are recruited. Women, many entering industrial work for the first time, become the backbone of the manufacturing workforce. Training programs operate around the clock. The factory becomes a living campus of American labor, reinventing itself hour by hour. But beneath this momentum lies a major problem. The B-24 is one of the most difficult aircraft ever attempted on an assembly line. Its high-aspect wings, Davis airfoil, and complex internal structure leave little room for error. Fitting components into its narrow fuselage proves harder than expected. Engineers worry that the Liberator simply wasn't designed for this kind of manufacturing. Ford refuses to turn back. Instead, the company reshapes the plane itself. Working with Consolidated Aircraft, they redesign sections, standardize fittings, and simplify joints. The B-24 evolves from a handcrafted bomber into the first truly modular heavy aircraft in American history. Still, the learning curve is brutal. Early attempts to start the line reveal misalignments, jigs that don't fit, and parts that arrive late or incompatible. Instead of one bomber per hour, Ford struggles to complete even one per week. But the factory is now too big to fail. Too much money invested. Too much national attention. Too many workers. Too many promises. Willow Run must succeed, not because the war demands it, but because American industry has staked its reputation on a single idea: that the modern world can be supplied not by heroism, but by production. By late 1941, Willow Run is no longer a blueprint, it is a rising monument of steel and ambition. Spread across more than 3.5 million square feet, the plant becomes one of the largest factories on Earth. Its construction alone is an engineering feat: foundations poured in winter, drainage systems carved into frozen ground, rail lines threaded into the site like veins feeding a body under construction. Inside, the scale borders on surreal. Workers describe the plant as a horizontal skyscraper, long, immense, and echoing with the sound of industry in its rawest form. From one end to the other, a person can walk for 20 minutes without seeing daylight. Concrete floors are polished to support thousands of rolling carts. Overhead conveyors form an industrial skyline, slowly transporting parts to their stations. But size is only the beginning. The factory's layout reflects Ford's obsession with flow, the relentless forward motion of materials toward completion. Raw aluminum enters one side of the building. Finished B-24 Liberators roll out the other, like an improbable promise made visible. Ford organizes the plant into specialized zones. Sub-assembly rooms handle the most intricate components: oxygen systems, flight instruments, hydraulic modules. At another section, wings stretch across jigs the size of houses. Riveters move in synchronized teams, each responsible for mere inches of metal, performing their task with mechanical precision. Still, the most dramatic challenge is the heart of the bomber: the fuselage. The B-24's design is notoriously cramped, with almost no room for error in fitting wiring, fuel tanks, and structural ribs. At first, the assembly line stalls as workers struggle to maneuver inside the narrow shell. Tools are redesigned. Procedures rewritten. Tooling crews create special fixtures to pre-fit components outside the fuselage, turning bottlenecks into manageable steps. Ford applies a concept rarely used in aviation: progressive assembly. Each segment of the bomber moves through the plant like a patient being operated on by hundreds of hands, none knowing the whole body, only their assigned gesture. It is industrial choreography. But a factory of this magnitude requires more than engineering. It requires people, and they arrive in waves. Tens of thousands migrate to Willow Run from across the country. Some move into hastily built neighborhoods. Others sleep in trailers, boarding houses, or converted barns. The region transforms overnight. Schools overflow. Buses run continuously. New stores open in the shadow of the factory. Willow Run becomes a city within a city, a community forged by urgency, opportunity, and war. The workforce is remarkable in its diversity. Men too old for the draft, women entering heavy industry for the first time, immigrants from the American South, former farmers, mechanics, and clerks, all thrown into a new world of machines and deadlines. Training programs operate day and night. Workers practice drilling, riveting, and inspection on scrap metal until their hands learn the rhythm of precision. Many have never touched aircraft components before. Yet within weeks, they perform tasks once reserved for skilled aviation craftsmen. Still, the pressure is overwhelming. Every hour lost, every mistake made, ripples up the chain. Supervisors monitor output with military intensity. Engineers patrol the lines looking for inefficiencies. Managers sense that Washington is watching and waiting. Outside, the world is spiraling toward catastrophe. Battles rage across North Africa, the Atlantic, and the Pacific. Britain pleads for more aircraft. The Soviet Union, reeling from the German advance, desperately needs American supplies. And the United States, soon to be thrust fully into war after Pearl Harbor, knows that the future depends on factories like Willow Run. Yet inside the plant, beneath the fluorescent lights and the smell of oil and aluminum, one truth becomes increasingly clear. Building the impossible is not about inspiration. It is about discipline. And the real test is still ahead. December 7, 1941 changes everything. When news of the Pearl Harbor attack reaches Detroit, the atmosphere inside Willow Run shifts instantly. What had been a national effort becomes a national emergency. The United States is now at war, and every bomber produced at Willow Run is no longer a theoretical contribution, it is a weapon needed immediately. Ford executives meet with military officials within hours. Production timetables are tightened. Output goals rise. The War Department demands the impossible: faster scheduling, higher precision, and greater volumes. Willow Run, still struggling to complete even a handful of bombers a week, is suddenly expected to become the beating heart of America's air power. The factory responds with a surge of energy. Recruitment accelerates. Entire shifts are added. Engineers rewrite workflow charts. The plant never truly sleeps anymore. Its machinery becomes a constant roar, day and night, echoing across the Michigan landscape. Workers speak of arriving in darkness and leaving in darkness, unsure whether it is morning or evening by the time they step outside. Yet despite the renewed urgency, the reality is grim. Willow Run is failing to meet expectations. The complexity of the B-24 continues to defy mass production. Subassemblies do not always align. Parts delivered from suppliers arrive late or out of tolerance. Jigs require constant adjustment. Aircraft must be rolled off the line and reworked on the tarmac, a costly and humiliating delay. Critics grow louder. Rival aircraft manufacturers insist that Ford has overreached. Military observers question whether an automobile company truly understands aviation. Even Henry Ford, usually confident and uncompromising, senses the weight of public scrutiny. Inside the factory, morale wavers. Workers feel the pressure of a nation depending on them. Supervisors push harder, walking the line with notebooks and tightened expressions. Inspectors become stricter, rejecting any component that fails to meet new wartime standards. Still, something begins to shift beneath the surface. The workforce grows more skilled with each passing week. New hires learn from veterans who themselves had been beginners only months earlier. Teams develop their own informal systems, signals, gestures, routines that help speed up work without sacrificing precision. The plant's culture, initially chaotic, slowly hardens into discipline. Outside the factory walls, the world provides constant reminders of what's at stake. Newsreels show Allied ships burning in the Atlantic. Reports from the Philippines describe desperate fighting. Soldiers write home asking for aircraft support. Every headline is a message to Willow Run: build faster. Ford responds by doubling down on engineering ingenuity. Tooling experts redesign jigs to allow quicker alignment. Subassembly lines are reorganized to reduce bottlenecks. Engineers simplify rivet patterns, strengthen weak joints, and standardize fittings across previously inconsistent sections of the airframe. And then comes one of the most transformative decisions. Ford brings manufacturing philosophy into the design of the aircraft itself. Working with Consolidated and the Army Air Forces, they reshape internal structures to improve assembly flow. The B-24 evolves, not just as a machine, but as a manufacturing object. For the first time, Willow Run feels like it might actually fulfill its purpose. Yet the pressure only grows. The attack on Pearl Harbor has pulled America into the largest conflict in human history, and the B-24 Liberator becomes essential for every theater. Anti-submarine patrols in the Atlantic, supply missions over the Himalayas, deep penetration bombing raids in Europe, and long-range strikes across the Pacific. But without Willow Run reaching full speed, there simply won't be enough aircraft. The nation looks to the factory. The factory looks to its workers. And the workers look to the line, waiting for the moment when everything will finally click. By early 1942, Willow Run stands at a crossroads. The factory is enormous, the workforce immense, the expectations towering, yet the output remains painfully low. Ford had once promised 1 B-24 per hour. Instead, the plant struggles to deliver even a few aircraft per month. Newspapers begin to whisper. Washington grows impatient. And Detroit understands that failure here is not just industrial, it is national. Inside the plant, early bombers reveal the harsh truth. Mass production exposes every flaw. Misaligned panels force workers to hammer components into place. Wiring looms are too stiff or too short. Sections built in distant supplier factories arrive with small imperfections that cascade into major fitting issues on the final line. Rivet lines wander. Doors jam. Crew compartments rattle with vibration. Each unfinished aircraft waits on the ramp for rework, and the backlog grows. For managers, walking the assembly line becomes an exercise in damage control. They carry clipboards filled with defect reports. Engineers huddle in corners, sketching last-minute fixes. Tooling teams race to adjust jigs that no longer hold tolerances. The plant feels less like an assembly line and more like an improvised battlefield. But beneath the chaos, something important is happening. The errors become data. Ford's engineers treat every misalignment, every failed inspection, every jammed panel as a symptom. They map defects across the entire factory. They identify which stations cause bottlenecks, which tasks require new tools, which subassemblies need redesign. Slowly, the improvisation begins to evolve into systemization. One of the most significant breakthroughs arrives when engineers realize that workers can't fit oxygen systems or electrical bundles into the aircraft once the fuselage is closed. The internal space is simply too narrow. The solution: pre-install components in open fuselage sections, then bring the segments together later. It is a radical rethinking of the Liberator's build sequence, and it works. Another leap comes through tolerance control. Suppliers are instructed to tighten machining standards. Ford creates dedicated inspection rooms where parts are measured with precision instruments before they ever reach the line. The philosophy shifts. It is cheaper to reject a component early than to fix it late. As improvements accumulate, the workforce begins to feel the difference. Jigs align more smoothly. Wing assemblies slide into place with fewer adjustments. Riveters notice that holes line up cleanly. What once demanded brute force now flows with mechanical logic. Still, the pressure never lifts. Military liaisons visit frequently, reminding the plant of urgent demands from overseas. Every liberator you finish, one colonel tells the workers, is a crew that lives. The message sinks deep into the culture of Willow Run. Workers begin writing notes inside aircraft panels, short messages like, "Good luck, boys," or "Bring her home." The factory becomes more than steel and schedules. It becomes a bridge between civilian sacrifice and military necessity. By the spring of 1942, training programs intensify. New supervisors emerge from within the ranks. Veterans teach newcomers not just the mechanics of their tasks, but the rhythm, the pace at which Willow Run must move if the war is to be supplied. The line grows louder, faster, more confident. And yet, success remains elusive. Despite improvements, output is still too low. Quality inspections remain harsh. Aircraft continue to pile up awaiting final corrections. Washington begins to question whether Ford should be allowed to continue running the plant. But the workers know something the outside world does not. Momentum is building. Small victories accumulate. Processes stabilize. The factory, once awkward and chaotic, begins to align like gears in a machine finding its proper mesh. The failures that once threatened Willow Run now serve as stepping stones, lessons paid for in sweat, hours, and determination. The factory is not succeeding yet, but for the first time, it is no longer failing. By mid-1942, the chaotic rhythms of Willow Run begin to settle into something new, something resembling true industrial flow. What once felt like improvisation now starts to resemble strategy. Every department, from tooling to inspection to final assembly, begins to speak the same mechanical language. One of the most important transformations occurs in the plant's internal logistics. At the beginning of the project, subassemblies arrived unpredictably, creating jams in one station and idle time in another. To fix this, Ford introduces a scheduling system modeled on the company's automotive experience. Controlled material flow. Parts must arrive not early, not late, but exactly when needed. Boxcars are rerouted. Warehouses are reorganized. Color-coded tags guide every pallet, crate, and container. The factory becomes a map in motion, a landscape where timing is as important as workmanship. Simultaneously, engineers redesign the assembly line's geometry. Instead of long, linear paths that trap bottlenecks, Willow Run adopts a branching structure. Subassemblies feed directly into the main line like tributaries into a river. Wings, fuselage sections, tail assemblies, engine modules, all meet the line at carefully calculated intervals. The system resembles a living organism, each part merging into the whole at the precise moment it is needed. With these changes, something remarkable happens. The line stops stalling. Another breakthrough comes from the introduction of stations of correction. Instead of pushing every flaw to the end of the line, teams of experts move along the process, fixing issues as they appear. It is a subtle shift, but it transforms quality control from punishment into prevention. Workers feel the difference immediately. Tasks that once required frantic improvisation now follow clear procedures. Riveters know when the next team will arrive. Electricians understand which subassemblies they will receive. Even inspectors, famous for their stern expressions, begin to nod with quiet approval. And finally, after months of setbacks, Willow Run completes its first liberators that require no major rework. The moment is celebrated quietly. There is no ceremony, no official announcement. But among the workers, a sense of pride radiates through the plant. They have proven what many in Washington doubted: mass-produced heavy bombers are possible. This shift in culture becomes the fuel that propels the next wave of improvements. Crews begin adopting informal, efficiency-boosting techniques. Riveting teams coordinate their hammer rhythms to reduce vibration. Welders develop shared shorthand for alignment calls. Toolmakers adjust jigs based on real-world feedback rather than blueprint theory. Newly trained women workers bring an unexpected advantage: smaller hands, steady precision, and an exceptional ability to repeat fine tasks without fatigue. Every improvement, however small, compounds through the line. Meanwhile, Ford implements a radical idea: open-air testing. Instead of waiting for finished aircraft to undergo long indoor inspection cycles, engines are run while the bomber sits on the ramp. Vibrations, leaks, and misalignments reveal themselves immediately. Crews fix issues on the spot, reducing bottlenecks and accelerating delivery. These changes begin to show in the numbers. Production inches upward. The plant, once known for delays, begins to deliver aircraft on schedule. Washington takes notice. Skeptical military officials begin to acknowledge the transformation. Even the press, once critical, starts reporting cautiously optimistic stories about the giant bomber factory. But perhaps the most significant shift is invisible to the outside world. The workers themselves now believe Willow Run can do the impossible. The early months had tested their patience, their skill, and their convictions. Now, for the first time, confidence replaces doubt. The plant still faces challenges, many of them enormous. But morale has turned. Procedures have solidified. And the once stumbling giant now shows signs of awakening. The gears are beginning to turn smoothly. And the real acceleration is still ahead. By late 1942, Willow Run is no longer just a factory, it is a world of its own. With more than 40,000 workers on the payroll, the plant has become a living city, complete with its own rhythms, tensions, rules, and culture. Inside its walls, American society is reshaped by necessity. The first thing newcomers notice is the noise. Not the simple clatter of tools, but a layered industrial symphony. The heavy punch of pneumatic riveters, the sharp crack of metal cooling, the rising whine of engines being tested at full throttle. Voices echo across concrete floors. Carts rattle down steel tracks. Overhead cranes rumble like distant thunder. Every sound is a reminder that the factory never sleeps. Shift changes resemble the movement of armies. Thousands of workers flood in as thousands flood out, a constant tide of men and women wearing oil-stained coveralls, carrying lunch pails, wiping aluminum dust from their sleeves. Some travel from nearby towns by bus or car. Others live in hastily built housing blocks that have sprung up around the plant like emergency settlements. These neighborhoods offer their own challenges. Streets fill with mud after rain. Stores struggle to keep shelves stocked. Schools become overcrowded. The influx of workers strains every service. But despite the hardship, the community pulses with purpose. People speak of Willow Run with a mixture of pride and exhaustion. It is difficult, overwhelming, chaotic, but it matters. Inside the plant, the workforce is remarkably diverse. Women now make up a significant portion of the line. Many have never worked with tools before, yet their precision and consistency quickly earn respect. "You want it done right?" one supervisor admits. "Give it to the women." They become essential in assembling instruments, wiring panels, turret components, and the complex hydraulic systems of the Liberator. African American workers, initially restricted to the most physically demanding tasks, gradually push into skilled positions despite resistance. The factory becomes a battleground for social progress as much as industrial achievement. While discrimination persists, wartime urgency forces change. Willow Run begins proving, shift by shift, that ability is not determined by background, gender, or color. Work on the line is demanding. The tasks are repetitive, but precision is unforgiving. Riveters must hit exactly the right angle. Sealers must brush compound into tight seams without missing a single gap. Electricians crouch inside cramped compartments threading wires through impossible spaces. Every mistake can compromise an aircraft thousands of miles away. Fatigue becomes a constant enemy. The factory runs 24 hours a day, 7 days a week. Night shifts blur into day shifts. Meals are eaten quickly, often standing. Marriages strain under the brutal hours. Children barely see their parents during peak production cycles. Yet workers push forward because the war demands it, and because few want to be the weak link in a chain that stretches across the ocean. Despite the pressure, moments of humanity break through the intensity. Workers develop rituals. A good section of wing assembly might earn applause. A completed fuselage rolling off the line inspires cheers. Teams sign their names inside hidden parts of the aircraft, private signatures in a machine that will soon cross continents. Camaraderie grows in the most unexpected places. Riveters swap techniques. Inspectors share lunch breaks with toolmakers. Veterans of the early chaotic months teach newcomers how to survive the pace. Supervisors learn that encouragement often works better than threats. Groups form identities, the spar crew, the nose section girls, the engine boys, each proud of its role in shaping the Liberator. One worker later recalls, "You didn't build a plane. You built your part of the plane. And you prayed the person after you cared as much as you did." By the end of 1942, this shared sense of mission creates something powerful, a collective heartbeat. Willow Run is no longer simply assembling bombers. It is forging a workforce capable of sustaining the largest air campaign in history. And while the B-24 is still far from rolling off the line at the promised pace, the people building them now move with purpose, and for the first time, with unity. The human engine has found its rhythm. Now the factory must catch up. As 1943 begins, Willow Run undergoes a transformation that will finally turn potential into performance. The plant's early struggles had revealed a simple truth: you cannot mass-produce an aircraft designed for handcrafted assembly. To make the B-24 a true production bomber, the factory must not just build it, it must reinvent it. And that is exactly what begins to happen. The first breakthrough emerges from Ford's tooling division. Engineers create an integrated set of jigs and fixtures that shape every major component with unprecedented consistency. Previously, each fuselage section carried subtle variations from one unit to another, fractions of an inch that cascaded into major assembly problems. Now, the new jigs lock every piece into precise alignment, eliminating hours of rework. At the same time, major structural components are divided into modular sub-assemblies. The B-24's complex internal bracing becomes a puzzle of standardized ribs and frames that can be built in parallel rather than sequentially. Sections that once took weeks can now be completed in days. Ford also introduces a radical innovation: unitized wing assembly. Instead of building the Liberator's high-aspect wings in fragmented pieces, Willow Run constructs entire wing modules complete with fuel tanks, hydraulics, and wiring already installed. When these massive sections arrive at the main line, they slide into position with almost theatrical precision. But perhaps the most transformative improvement comes from a subtle change in mindset. The factory no longer treats aviation as a special craft, it treats it as a system. Engineers no longer ask, "How do we build this part?" Instead, they ask, "How does this part move through the line?" This shift drives the next wave of progress. Toolmakers simplify processes, reducing the number of steps required for each station. Material flow experts reorganize supply chains to ensure consistency. Quality inspectors collaborate directly with assembly teams, preventing defects instead of merely detecting them. Layout specialists adjust line spacing, allowing more workers to operate simultaneously. Even small adjustments, a redesigned clamp, a newly shaped drill guide, a refined riveting gun, shave seconds off tasks. And those seconds accumulate into hours, then days, then measurable production increases. To accelerate the transition from design to implementation, Ford forms what becomes known as the Red Team. These are task force groups of engineers with authority to bypass bureaucracy. If a jig must be rebuilt, they rebuild it. If a process must be rewritten, they rewrite it. Their mission is simple: eliminate anything that slows the line. With each improvement, the factory begins to feel different. The once awkward choreography of the line becomes smoother, more confident. Sub-assemblies arrive on time. Cranes swing into place with practiced ease. Workers notice that parts fit more naturally, that tasks require less force, that the Liberator's skeleton closes more cleanly around their hands. But the greatest sign of progress comes in the form of time. A year earlier, the assembly of a single Liberator could stretch over weeks. Now, the factory completes one in a fraction of that time, and the pace continues to rise. The U.S. Army Air Forces take note. Officers visiting the plant see a facility finally living up to its promise. Where they once saw confusion, they now see coordination. Where they once doubted, they now believe. Ford executives describe the moment as the factory crossing the threshold. It is not yet producing bombers at full speed. Far from it. But the machinery of mass production has finally begun to turn freely. American industry is learning how to fight a global war. And Willow Run is becoming its proving ground. By mid-1943, Willow Run undergoes a transformation that feels almost physical, as if the factory itself exhales, finds its balance, and steps into a stride it had been trying to reach for nearly 2 years. The long-awaited ramp-up has begun. Output numbers, once embarrassing, now climb steadily. Where the plant had produced aircraft in small, inconsistent batches, it now delivers Liberators in regular, disciplined intervals. A rhythm takes hold, powerful and unmistakable, a new bomber rolling out onto the flight ramp day after day, its aluminum skin flashing in the Michigan sun. Inside the plant, workers sense the shift immediately. Stations that were once bottlenecks now operate with confidence. Parts fit together with a precision that would have been unthinkable in the early months. The line no longer feels like a battlefield, it feels like an orchestra. The transformation becomes most visible in the final assembly area. For months, this section had been the graveyard of delays, where misalignments compounded and unfinished aircraft waited for rework. Now, fuselages move through the final stations with surprising smoothness. Engines arrive tested and ready. Turrets fit without modification. Control surfaces balance cleanly. Even inspectors, notorious for their uncompromising standards, begin to report fewer critical defects. One supervisor describes the change with simple clarity. Willow Run stopped fighting itself. Training programs mature. Workers who had once struggled with basic tasks now teach advanced techniques to newcomers. Departments develop reputations. The wing shop for its speed, the fuselage team for its reliability, the engine line for its near-surgical precision. The atmosphere on the floor changes as well. Fatigue remains, but morale rises. Workers begin competing, not against each other, but against their own previous records. A faster panel installation, a cleaner rivet line, a perfectly aligned bulkhead, each improvement becomes a shared victory. Efficiency boards track metrics in real time, and teams take pride in outperforming expectations. Meanwhile, Ford's logistics network evolves into a masterpiece of wartime engineering. Trains roll into the plant loaded with engines, aluminum, wiring harnesses, hydraulic modules, and crates of specialized instruments. Forklifts deliver these supplies in a timed choreography. Conveyor belts hum with consistent flow. For the first time, no station waits for parts. The plant begins producing not just aircraft, but predictability, the most valuable commodity in wartime manufacturing. Outside the factory walls, the world feels the impact. The U.S. Army Air Forces expand their strategic plans based on the expectation of continuous B-24 deliveries. Missions that were once limited by a shortage of long-range bombers now take shape with newfound confidence. Liberators built at Willow Run head to every corner of the globe. Over the Atlantic, hunting U-boats. Across Europe, pounding industrial targets deep inside enemy territory. In the Pacific, striking islands separated by vast distances. Over the Himalayas, hauling supplies to China in brutal weather. The factory's output begins to reshape the tempo of the war. Yet despite the progress, Ford executives and military officials know that Willow Run has not reached its peak. The plant is improving, but it is still becoming. The systems are strong, but not yet perfect. The pace is accelerating, but not yet maximum. Still, something remarkable has happened. Willow Run is finally producing at a level that justifies its existence. The dream that once seemed impossible, mass-producing a 4-engine heavy bomber, is no longer a dream. It is reality, rolling off the ramp one aircraft at a time. The factory that had stumbled, struggled, and nearly collapsed under its own ambition has found its footing. And the world will soon witness what happens when it begins to run at full speed. By early 1944, Willow Run reaches a milestone so staggering that it becomes legend, the ability to produce one B-24 Liberator every hour. For a bomber with more than 450,000 individual parts, this rate borders on the unbelievable. Yet here, in a factory once dismissed as a reckless experiment, the impossible is now routine. The transformation is visible the moment one steps inside. The plant, once characterized by confusion and stop-and-go inefficiency, now functions with the precision of a clock driven by steel and human will. Every station, every worker, every tool fits into a vast mechanical rhythm. Fuselage panels glide into position with minimal adjustment. Wing modules arrive ready to mate with the center section. Tail assemblies swing overhead on massive cranes, descending gently onto jigs prepared exactly for their contours. The line flows like a river, steady, unbroken, and relentless. Workers at this stage describe the atmosphere as electric. They know they are part of something historic. Teams take pride in pushing the boundaries of productivity, chaining tasks together, synchronizing movements, refining handoffs so smoothly they become ritual. A riveter once said, "We didn't just know our job, we knew the job of the person before us and the person after us." Efficiency becomes a culture. Ford's management introduces real-time tracking boards displaying output, timing, and targets. When the plant hits a new record, cheers ripple through the line. When performance dips, teams gather to identify the source, correcting without waiting for supervisors. The plant begins running itself, a self-correcting organism. Quality improves alongside quantity. Contrary to fears that faster production would degrade reliability, inspection reports show the opposite. The new workflows reduce errors by eliminating improvisation. Parts fit because tolerances are controlled. Systems function because they are tested earlier and more consistently. The Liberators rolling off the line in 1944 are among the best ever produced. The hour-by-hour tempo shapes every corner of factory life. Trains arrive at precisely timed intervals, unloading engines and components with military discipline. Supply teams move material with the urgency of battlefield logistics. Forklifts weave through aisles with practiced certainty. Even the cafeteria operates at speed. Workers eat in shifts aligned to the rhythm of the assembly line. The technical choreography reaches its climax in the plant's final assembly section, where completed Liberators receive engines, landing gear, and final systems checks. From there, the aircraft roll toward the end of the building, the mile-long journey completed, and emerge into sunlight for the first time. It is here that the scale becomes fully real. Dozens of bombers sit on the ramp, lined up in perfect rows. Engines idle. Crew chiefs inspect instruments. Test pilots circle their future missions in notebooks. Each aircraft represents thousands of hands, millions of parts, and a nation's determination. Test flights become the final ritual. Pilots describe Willow Run Liberators with respect. Solid, reliable, and consistent across airframes. For the first time in the war, long-range operations in both the European and Pacific theaters receive a continuous stream of new aircraft. The numbers tell the story best. Willow Run becomes the largest bomber factory in the world. At peak, the plant produces more than 400 bombers per month. Over the course of the war, it will deliver nearly 9,000 B-24 Liberators. But beyond numbers lies a deeper truth. The 1-per-hour milestone proves something fundamental about American industry. When coordinated at scale, guided by engineering discipline, and driven by national purpose, it can reshape the outcome of a global conflict. The factory built to challenge the limits of production has now exceeded them. Willow Run is no longer catching up, it is leading. And the world's largest air war is about to feel the full force of that momentum. By mid-1944, the impact of Willow Run begins radiating far beyond Michigan. The factory's output transforms not only American air power but the strategic landscape of the entire conflict. For the Allies, the arrival of hundreds of new B-24 Liberators every month is more than industrial success, it is the foundation of a global shift in momentum. No theater feels this change more strongly than the Atlantic. For years, German U-boats dominated the shipping lanes, sinking freighters faster than they could be replaced. The Atlantic was a graveyard of steel, and the survival of Britain depended on breaking the U-boat stranglehold. Early in the war, Allied aircraft lacked the range to patrol the mid-Atlantic air gap, a vast stretch of ocean where convoys were exposed. Willow Run changes that. With Liberators pouring off the line, the U.S. Navy and Royal Air Force finally possess long-range patrol bombers capable of covering the entire North Atlantic. These new B-24s are outfitted with radar, searchlights, sonobuoys, and improved depth charges, weapons perfectly suited to anti-submarine warfare. Their extended patrol range closes the air gap entirely. The effect is immediate and devastating. U-boat sinkings rise sharply. Convoys survive crossings that would once have been slaughter. German submarine commanders begin describing the sky as haunted, patrolled by bombers that seem to appear out of nowhere. For the first time in the war, the Allies control the Atlantic. And Willow Run's output is one of the key reasons why. In Europe, the Liberator becomes the backbone of long-range bombing. The aircraft's ability to fly farther than the B-17 makes it ideal for deep penetration raids into Germany, targeting factories, oil refineries, and critical infrastructure. Entire bombardment groups fly missions using Willow Run aircraft, coordinated strikes involving hundreds of Liberators moving across the sky like formations of migrating giants. Pilots trust the reliability of the later model B-24s. Airframes are consistent. Systems respond predictably. Maintenance crews appreciate that parts are standardized, reducing downtime between missions. The factory-style discipline of Willow Run's production line translates directly into airfield efficiency half a world away. In the Pacific, the Liberator becomes a strategic weapon of range. From bases in the Solomon Islands, New Guinea, and later the Marianas, B-24s launch missions across vast oceans to strike Japanese positions that were previously unreachable. Their long legs enable reconnaissance over immense distances, mapping targets and tracking fleet movements. Supply lines once considered impossible to defend suddenly gain a shield of airborne vigilance. The aircraft built in Michigan begin shaping battles thousands of miles from the nearest factory. And yet, the influence of Willow Run extends even further. Its success teaches an essential lesson: mass production can overcome technological asymmetry. The Axis powers may field advanced, even extraordinary, weapons, but they cannot match the sheer volume of American output. The B-24 becomes a symbol of that reality. Not the perfect bomber, but the bomber that exists in overwhelming numbers. This shift in industrial philosophy spreads across American manufacturing. Plants producing tanks, jeeps, ships, and ammunition adopt Willow Run's modular workflows and process controls. In many ways, the factory becomes a blueprint for how the United States wages modern war, not through singular heroics, but through organized, relentless production. Military planners begin constructing strategies around the assumption that Willow Run will continue to deliver. Air campaigns expand. Naval operations take new risks. Intelligence services coordinate missions knowing they will have aircraft available for rapid redeployment. The war is changing, not just because of battles fought on frontline soil, but because of what happens inside a mile-long factory built on farmland in Michigan. By the end of 1944, it becomes clear. Willow Run hasn't just built bombers. It has helped build a new kind of warfare, one driven by industry, speed, and the power of scale. And the next phase of that transformation is about to begin. By early 1945, Willow Run stands as a symbol of industrial triumph, but behind that triumph lies a tremendous cost, paid not only in dollars and machinery, but in human endurance. Sustaining the highest production tempo of the war pushes every part of the system to its limits. On the factory floor, the strain becomes unmistakable. The line runs 24 hours a day, 7 days a week. There is no pause, no season, no schedule beyond the relentless march of bombers moving from station to station. Workers endure long hours and rotating shifts that disrupt their sleep cycles. The constant roar of the plant, a mix of riveting hammers, welding torches, cranes, and engines on test runs, becomes a second environment, one they carry home in their ears at night. Fatigue breeds mistakes, and mistakes threaten the line. Supervisors learn to read the signs: slowed movements, unfocused eyes, repeated errors. Management responds with measures that are half compassionate, half strategic: more breaks, better lighting, improved ventilation. But these can only mitigate, not eliminate, the pressure of a factory designed to push human and mechanical systems to the edge. The physical toll is matched by emotional strain. Workers worry about sons, brothers, or husbands fighting overseas. News of losses on the front lines spreads quickly. A name mentioned in a telegram becomes a quiet shadow over the next shift. Conversations during breaks often shift between work and war, productivity and fear. Housing shortages around Willow Run add another layer of stress. Families crowd into small, hastily built apartments. Winter drafts seep through thin walls. Long bus rides to the plant stretch the workday even further. Yet despite these hardships, absenteeism remains surprisingly low, a testament to the workers' commitment. But the factory itself also begins to show signs of exhaustion. Machines run hot. Tools wear down faster than they can be replaced. Cranes require constant maintenance. Entire sections of the plant need recalibration. The logistics network, strained by full-capacity operation, struggles to keep the line fed with raw materials. A single missing shipment of aluminum sheets or engine parts can jeopardize an entire day's schedule. To combat this, Ford establishes a round-the-clock repair and maintenance division. Technicians roam the plant like battlefield medics, diagnosing mechanical problems before they halt production. Spare parts are stockpiled. Jigs are recalibrated between shifts. Engineers redesign tools on the fly to prevent recurring failures. The result is a factory that feels not static, but alive, a living system constantly healing itself. The war's expanding demands also amplify the pressure. Operations in Europe and the Pacific require more aircraft, not fewer. The Army Air Forces add new specifications for field modifications. Bomb racks change. Radar systems evolve. Armor plating is reinforced. Each modification ripples down the line, forcing Willow Run to adapt without slowing pace. Adaptation becomes a daily routine. When a new turret design arrives, workers train overnight. When engine upgrades are approved, logistics teams rewire supply chains. When the Army requests faster turnaround, the line accelerates without protest. What makes this adaptability possible is not just engineering. It is the experience forged through years of trial, error, and relentless improvement. Willow Run's workforce knows how to pivot. They have survived the plant's chaotic birth, endured its failures, and mastered its systems. Now, in the war's final chapter, they apply that hard-earned discipline with quiet efficiency. Yet no matter how effective Willow Run becomes, the underlying truth remains. Mass production at this scale is unsustainable forever. The war has turned a generation of civilians into industrial soldiers. And like any army, they carry scars, physical exhaustion, strained families, missed milestones, and years spent living to the rhythm of a machine. Still, they push forward. Because the war is not yet won. Because the Liberator is needed in the skies. And because a factory built to achieve the impossible cannot stop until the job is done. As Willow Run pushes into 1945, its B-24 Liberators fly across every major theater of the war. The aircraft rolling off the Michigan assembly line no longer represent abstract production numbers. They are the machines carrying young aircrews into some of the most dangerous missions ever attempted. And the battlefield proves just how critical Willow Run's consistency has become. In Europe, B-24s join massive strategic bombing operations against Germany's industrial heart. The missions are brutal. Liberators must cross hundreds of miles of hostile airspace, exposed to flak bursts that fill the sky with shrapnel and to waves of enemy fighters attacking from every angle. Crews describe the experience as flying through steel rain. Here, the standardization achieved at Willow Run becomes a matter of life and death. Maintenance crews at bases in England and Italy quickly learn that no matter which aircraft rolls into their dispersal area, the systems will match. The wiring is where they expect it. The hydraulic lines follow the same path. The engines mount cleanly. Spare parts fit every airframe. This predictability allows ground crews to turn aircraft around faster, repair battle damage with less delay, and prepare entire squadrons for missions that must launch precisely on schedule. It is the invisible backbone of air warfare, made possible by the same principles that drive Willow Run's assembly line. Crews develop deep respect for the B-24's endurance. Its long range makes it the ideal bomber for deep strikes into Germany, Ploieschti, Brunswick, Regensburg, the industrial Ruhr. Missions that push other aircraft to their limits become standard operations for Liberator groups. And although the B-24 is not as beloved as the B-17, often called less stable, more cramped, harder to fly, its strategic value is undeniable. Where the B-24 truly shines is range. That single strength reshapes entire campaigns. Over the Atlantic, Willow Run Liberators fly with specialized radar and long-range fuel systems. They patrol vast ocean stretches that were once death traps for Allied convoys. Their presence reduces U-boat attacks so dramatically that German submarine commanders begin referring to the mid-Atlantic as the hunted zone. Again and again, Liberators sink submarines, drive wolf packs away from trade routes, and force the German Navy into a defensive posture it never recovers from. In the Pacific, the Liberator becomes the spearhead of island-hopping operations. With its ability to fly long distances over water, the aircraft hits targets far beyond the reach of shorter-range bombers. From bases in the Central Pacific, B-24s strike airfields, supply ships, fortifications, and troop concentrations across dozens of islands. On these missions, reliability matters even more than in Europe. A mechanical failure over ocean often means no return. The consistency of Willow Run construction, the aligned joints, standardized systems, predictable engine performance, gives crews confidence that their aircraft will make it home. One pilot later recalled, "If it came from Willow Run, you trusted the airplane. You still feared the enemy, but not the machine." In Burma and India, Liberators serve in transport and reconnaissance roles. They fly over the Himalayas on the infamous Hump Route, carrying fuel and supplies to Chinese forces fighting the Japanese. Conditions on these flights are among the most extreme faced by any aircraft in the war: freezing temperatures, violent turbulence, and minimal margin for error. Yet the Willow Run-built B-24s perform with astonishing resilience. Everywhere they fly, the same story repeats. The B-24 is not perfect, but it is effective, brutally, strategically effective. And that effectiveness belongs not only to the crews who fly the aircraft, but to the armies of workers, engineers, inspectors, and logisticians in Michigan. The men and women of Willow Run never see the battlefields, but the outcomes of those battles reflect their labor. Each mission completed, each convoy protected, each submarine sunk, each target destroyed, is part of the factory's legacy. The B-24's combat record is inseparable from the industrial miracle that produced it. And as the war enters its final phase, that miracle becomes even more crucial. By the spring of 1945, Willow Run is running at such extraordinary efficiency that it begins producing more aircraft than the war can immediately absorb. What had once been a desperate race to equip Allied forces has shifted into a situation no one in 1941 could have imagined. American industrial power is outpacing military demand. It is a strange, almost surreal moment in the factory's history. The line continues to operate with the momentum of years of refinement, but outside its walls, the strategic equation is changing rapidly. Germany is collapsing under the combined pressure of Allied armies and relentless air campaigns. Cities that were once targets for B-24 raids lie in ruins. Luftwaffe resistance, once fierce and deadly, dwindles as fuel shortages and pilot losses cripple German defenses. For the first time, bomber groups across Europe begin reporting something unheard of earlier in the war: days where there simply aren't enough significant targets left to justify full-scale missions. On the ground in Michigan, the news reaches Willow Run with a mixture of pride and unease. The workers know what it means. They feel the shift. Even as the mission briefings change, the factory maintains peak output. Crates of engines, hydraulic modules, and assembled turret systems continue to arrive. The line moves at full stride, a mile-long machine of steel, sweat, and discipline that does not know how to slow down. But military planners do. They begin to ask difficult questions. How many B-24s will be needed in the final months of the war? How many should be sent to the Pacific? What role will heavy bombers play once Germany is defeated? The Pacific is still raging. Japan remains determined, entrenched, and far from surrender. Long-range bombers continue to be essential for reconnaissance, anti-shipping missions, and strikes on island fortifications. But even here, the B-24's role is beginning to evolve as new aircraft, especially the B-29 Superfortress, enter mass production. And so, by mid-1945, Willow Run faces an unfamiliar problem. The future no longer demands limitless liberators. Inside the plant, this shift manifests in subtle changes. Supply quantities are quietly adjusted. Army Air Force's representatives begin attending meetings with more questions than orders. Rumors spread across the factory floor, some claiming the line will shut down within months, others insisting production will shift entirely to Pacific-focused variants of the Liberator. For many workers, the uncertainty is unsettling. The factory has been their world. They have lived to its rhythm, endured its strain, and taken pride in its purpose. The idea that this monumental machine might soon slow, or stop, feels almost impossible. Management addresses the workforce with cautious optimism. Ford executives praise employees for their historic achievement and assure them that decisions will be guided by the needs of the nation. But everyone knows that the tone has shifted. The urgency that once defined every movement of the line is gradually fading. At the same time, the industrial lessons learned at Willow Run reshape American thinking about production long after the war. Engineers from across the country visit the plant, studying the assembly processes, logistics flows, and tooling innovations that made 1-per-hour output possible. Military officers report that Willow Run has become a blueprint for the future of wartime manufacturing, a model of how to mobilize a nation. Yet the most profound change is internal. For the first time since 1941, the workers at Willow Run confront the idea of an ending. They built an industrial giant to save the world from tyranny. Now that tyrannies are falling, the giant finds itself without a clear enemy. As victory approaches, the factory that once symbolized urgency becomes a symbol of something else entirely. A nation that has mastered industrial warfare, and must now decide what to do with that mastery. On May 8, 1945, VE Day, sirens erupt across the United States. Cities celebrate in the streets. Church bells ring. Factories pause for a moment of collective relief. The war in Europe is over. At Willow Run, the news arrives like a change in air pressure. There is joy, of course, genuine, unfiltered joy, but also a strange, quiet tension. The factory that once raced to meet unending demand suddenly faces a world where its central purpose is dissolving. The line does not stop immediately. The Pacific War is still raging. But everyone knows that the end is now visible on the horizon. Production continues at high tempo through the summer. B-24 Liberators still roll out of the massive hangar doors, engines gleaming, their aluminum skins reflecting the Michigan sun. Many of these aircraft are bound for the Pacific, where long-range bombing, anti-shipping patrols, and reconnaissance remain essential. Yet even here, the writing is on the wall. The B-29 Superfortress, a technologically advanced successor, is taking center stage in the strategic bombing campaign against Japan. Willow Run's Liberators continue to serve, but they are no longer the spearhead of American air power. Their missions shift toward support roles, maritime patrol, and secondary strikes. Then August arrives. Hiroshima, Nagasaki, and finally, on September 2, 1945, Japan surrenders. The Second World War is over. Across the United States, production orders are canceled almost overnight. Shipyards, tank factories, and aircraft plants experience a wave of abrupt stillness. Willow Run is no exception. After years of running at full throttle, years defined by urgency, sacrifice, discipline, and sheer mechanical force, the line finally begins to slow. Workers describe the moment as surreal. Stations that once buzzed with motion now stand quiet for minutes at a time. Cranes hang motionless above unfinished airframes. Tool racks sit untouched. The factory that had pulsed like a living organism begins to settle into silence. For many, The silence is unsettling. The noise had been brutal, but it had meant purpose. Now, purpose feels uncertain. Tens of thousands of workers face layoffs as military contracts evaporate. Some return to their hometowns. Others search for work across Michigan's shifting industrial landscape. A few remain, helping wind down production or transition the plant for new roles. Ford must decide what comes next for the massive complex. A factory built for a global emergency now seems oversized for peacetime needs. Negotiations begin over whether the government will purchase the plant outright, repurpose it, or shut down major sections. Equipment is mothballed. Storage yards fill with surplus materials. The entire facility seems to exhale, a long, exhausted breath after years of unbroken activity. Yet even in this quiet, the achievements of Willow Run remain undeniable. The factory produced nearly 9,000 B-24 Liberators, the largest output of any heavy bomber plant in history. It proved that mass production could be adapted to aircraft of unprecedented complexity. It showed that a nation's industrial capacity could be mobilized with speed and precision unmatched by any adversary. And it demonstrated that ordinary workers, when united by a shared mission, could perform extraordinary feats. As the post-war months unfold, people begin to look back on Willow Run not simply as a workplace, but as a phenomenon. Veterans returning from Europe and the Pacific speak with awe about the sight of rows of Liberators, identical and reliable, waiting on the ramps of airfields. Families remember the sacrifices they made to support the war. Engineers reflect on technical breakthroughs that will guide manufacturing for decades. And historians will one day note that, while armies fought on the front lines, the outcome of the war was shaped just as profoundly by factories like this one. Places where steel, labor, and discipline combined to tip the balance of global power. The machines have begun to quiet. But the legacy they forged has only begun to echo. In the months after the war, as the machinery cools and the hangar doors close for the last time, the deeper legacy of Willow Run becomes clear. What happened in that mile-long factory did not end with the final B-24. Instead, it triggered a transformation that would ripple through American society, technology, and industrial philosophy for generations. Willow Run proved that mass production could be applied to machines far more sophisticated than automobiles. Before the war, many believed aircraft were too complex, too delicate, too dependent on craftsmanship to be built on a moving line. The B-24 shattered that belief. It showed that with the right tooling, modular design, and organizational discipline, even the most intricate machines could be produced at breathtaking scale. This realization changed the world. In Detroit, manufacturers integrated Willow Run's methods into peacetime production. Assembly lines became more flexible, capable of shifting between models and products with unprecedented speed. Precision tooling, once a niche specialty, became a standard expectation across industries. The wartime emphasis on quality control accelerated the adoption of statistical methods and process engineering that still shape modern manufacturing. In aviation, the lessons were even more profound. The post-war aircraft industry embraced modularity, pre-assembly, and standardized components. Techniques pioneered at Willow Run influenced the production of jet fighters, long-range bombers, commercial airliners, and eventually spacecraft. When the space race began, many of the engineers who had cut their teeth at Willow Run brought with them an instinct for building the seemingly impossible. But the legacy wasn't solely technical. It was human. The workforce at Willow Run, men and women, black and white, migrants from the South, immigrants, former farmers, mechanics, students, represented a cross-section of America forced to collaborate at industrial speed. For many women, Willow Run was their first experience in skilled manufacturing. They proved their ability beyond question. Although many were pushed out of these roles after the war, the cultural impact of their success helped lay the groundwork for the women's labor movements of the decades to come. African American workers, too, fought for and earned places in skilled trades at the plant. Their progress at Willow Run contributed to the early tides of the civil rights movement, challenging prejudices that had long restricted opportunity. The factory also reshaped the concept of national power. For generations, military strength had been defined by armies, fleets, and individual weapons. Willow Run, and the broader arsenal of democracy, introduced a new idea, that the true measure of power lay not only in the battlefield, but in the production lines that supplied it. In an era of total war, the side that could replace machines faster than they were destroyed held an insurmountable advantage. World War II was the proving ground for that idea. Willow Run became one of its defining symbols. In the decades that followed, scholars, engineers, and military planners studied the plant as a case study in large-scale logistics, human organization, and manufacturing psychology. Its successes and failures became essential lessons in how to mobilize a nation, not just in wartime, but in any era that demanded speed, coordination, and innovation. Yet for all the grand narratives, the human memory of Willow Run remains grounded in the personal stories of those who worked there. Many speak of exhaustion and sacrifice, but they also speak of pride, a quiet, enduring pride in knowing that a piece of the aircraft that helped win the war passed through their hands. That the noise, the sweat, the long nights, and the relentless rhythm meant something. In a very real sense, Willow Run was a bridge between the America that entered the war and the America that emerged from it, an America more capable, more coordinated, and more confident in its industrial strength. The war ended. The line shut down. But the idea it proved, that free citizens, organized with purpose and armed with knowledge, can build anything, lives on. In the decades after the war, Willow Run becomes many things: an airfield, an industrial park, a memory whispered in veterans' reunions, a chapter in engineering textbooks. But long before historians give the plant its place in the narrative of the 20th century, those who lived through its rise already understood what it represented. They had felt it. They had built it. They had watched it reshape the war. To understand Willow Run's true significance, one must look beyond the production numbers, beyond the blueprints, beyond the miles of assembly lines and the thunder of machinery. Its real achievement lies in the convergence of three forces that, together, changed the course of history. First, Willow Run proved that America could mobilize on a scale unmatched by any nation on Earth. When the world needed aircraft, the United States delivered not dozens or hundreds, but thousands, produced with the consistency of a clock and the urgency of a race for survival. Second, it demonstrated that technological complexity could be conquered by organization. The B-24 was not an easy airplane. It was demanding, fickle, cramped, and structurally intricate. But Willow Run showed that complexity is merely a challenge of coordination, that with the right tools, processes, and human resolve, even the most sophisticated machines can be produced with industrial precision. Third, and perhaps most important, Willow Run revealed the power of collective effort. Tens of thousands of workers, young and old, men and women, from farms, cities, and small towns, came together to build a machine that would shape the fate of millions. Most had never touched an aircraft before the war. Yet by its end, they possessed skills and discipline that once belonged only to craftsmen and engineers. Their achievement was not a miracle. It was work. Hard, disciplined, relentless work. And that is what makes Willow Run extraordinary. By the time the factory shut down, it had produced nearly 9,000 Liberators, more than any other plant in the world. These aircraft hunted submarines, shattered oil refineries, delivered supplies over mountain ranges, and carried young men through some of the most dangerous skies ever flown. They changed campaigns. They protected convoys. They enabled strategies that would otherwise have been impossible. If wars are decided by logistics, and many historians argue they are, then Willow Run was one of the decisive engines of Allied victory. Looking back, it becomes clear why the plant earned its unofficial title during the war. The factory that defeated Hitler. Not because it fought on the front lines. Not because it built the most glamorous airplane. But because it proved that in a conflict defined by scale, discipline, and endurance, industrial strength could be as decisive as military strategy. Today, the physical plant survives only in fragments. Much of its vast floor space has been repurposed or demolished. But the legacy of Willow Run lives on in the technologies it inspired, the production philosophies it proved, and the generations of engineers shaped by its example. More importantly, It lives in the understanding that when free societies commit themselves to defending their ideals, they can summon a force greater than any single weapon. The coordinated effort of millions of ordinary people, working toward one extraordinary goal. The men and women of Willow Run did not carry rifles. They carried drills, rivet guns, wrenches, pencils, blueprints, and determination. Their battlefield was steel. Their weapon was discipline. Their victory was measured not in territory gained, but in the aircraft that rolled into the sunlight at the end of a mile-long line. And through that victory, they helped shape the world we live in.